In this video, I will talk about multithreading applications in Java. Java is a multithreaded programming language, which means that Java provides us ability to develop multithreaded programs, and a multithreaded program can contain several parts that can run concurrently, and each part can handle a different task at the same time, making optimal use of the available resources. So these parts also call it threads. So multithreading enables us to write in a way where multiple activities can proceed concurrently in the same program. So there are several reasons why we can need these threads, multi-threading applications. It's the first is to be able to better utilize the resources in the computer. So, for example, if one thread is waiting for response to a request sent over the network, then another thread could use the CPU in the meantime to do something else. Also, the second reason is to better utilize of multiple CPUs and or CPU cores. So, in modern computers, usually have multiple CPUs or CPU cores. Uh, so using single-threaded applications, we can just use only one CPU, and it will not be optimal for us. So multi-threaded applications provide us the ability to utilize all the resources we have. Also, third reason is provide a better user experience with regards to responsiveness. So, for example, client can start long time process by clicking one button, but in this case, it will not be. It will be better if client can do something else uh, until this process finishes. So in this case, in single-threaded applications, this will just so client have to wait the program to respond if to a long time until this process is finishes. With using multi-thread application, we can at least just create something like progress bar to show or illustrate clients that process is going on, not crashed. Also, multi-thread applications provide us better user experience with regards to fairness. So, with multi-thread applications, we can just serve several clients using that using multiple threads for each client. So, multi-threading has also benefits and drawbacks. So, as I said, benefits are that better CPU utilization, simpler program design, more responsive programs, and more fair distribution of CPU resources. Drawbacks are that more complex design, context switching overhead, increased resource consumption. So, Java threads is like a virtual CPU that can execute your Java code inside your Java application. When a Java application started, its main method is executed by the main thread. So, and yeah, specials and any code we wrote will be in the main thread. Using thread class, we can just create our own thread and then start it simultaneously with the main thread. So, thread class lifecycle is demonstrated here. So when we create thread object of this thread class, then it will be in state new until this thread starts. When it's started, it will take state runnable, and then when CPU will be available, it can just take state running. So also with IOT method, we can just take away to another state. So IOT method says that we are not hurrying. The next one of the threads can take the queue can take this process this resource and it will take runnable state, and so it will just in some times it will take running state depending on the operating system. So also we can use suspend sleep wait methods to block our state or thread, so it will take blocked state or so waiting state. So in this case blocking state and then when thread is terminated it will take dead state. Creating and starting threads. So we can just directly extend the thread class and then implement its run method to create our thread, or we can use another class and with runnable interface, so we can just extend this interface or implement or use it as anonymous class in this method, so we can implement its run method to write code to run in a different state. So let's see. So in this case, for example, we can use like here extending thread class like this, or we can use a runnable interface, so we can create any class like here, for example public. So in this case we can just extend any another class instead of thread. Also we can just implement runnable. So also we can just implement like this, or new version from the 8th version of the Java. We can just use lambda expression because runnable is a functional interface. Lambda expression like this So to start threads in any way, we should use a start method of the thread object. So in this case, we shouldn't confuse start method with run method because we can use run method in our code, but in this case, uh, this code run it will be run will run not in a different state. It will run in a same thread with our in our main thread if we run it from the main thread. So the commonly used methods are listed here. So also you can see here the thread class methods of the thread class. So in this case, start method used to start execution of the thread. Sleep method to make the thread sleep in a special time, so we can just uh, specify it in milliseconds using argument. Also, we can get name of the thread. We can set name of the thread. Set name method has. We can set priority and get priority of the thread. So in this case, priority it will take priority, but it will not just guarantee execution because it's depend on operating system. Also, we have IOT method, static method IOT, so causes current thread on halt and on other thread to execute. So you say that. So thread can, it will be like you say that I'm not hurry, so anyone can go. I can just wait for a time. So also it will just take runnable state as I showed before. Also join method, so which waits until that thread has finished its execution. So and continue doing anything. Also is a leaf method to determine if a thread is running. So let's see some examples. So in this case, join method. So we can just join it. So for example, this thread is just prints R1 and then sleeps for 500 milliseconds. So and prints R2. So let's run it and see it. So in this case, thread null. So it waits for finishing thread null and then T1 and then runs the thread 1, so T2 started. Next. So it's runnable. So it just starts thread 1 and joins it for a second and then starts thread 2. It's the same example. So in this case, we join it. We are waiting only 1 second. Sleep it for 4 seconds. So in this case, so we can just specify time to the join method and then so it started before finishing of the thread 1. If you say, if you can see, so waited enough, so it enters and thread 1 exited after this line of code. Also, to communicate between threads, we can use wait, notify all methods. So in this case, it's object classes methods. So in this case, wait method tells the thread to give up the lock and go to sleep until some other thread enters the same monitor and calls notify. So monitor means that object from where we just call it wait method, and the notify method will just wake up one single thread that call it wait, but it will not guarantee which thread. It will not say, we cannot specify which thread will be waken up. So if several threads waits for this object with the same monitor, then notify method will be just randomly select uh, the thread and then notifies and then wakes up, so it will continue working. Notify all method will wake up all threads which waits in a same monitor, same object. So let's see it in example. So intersect. In this case, we have two threads which waiter and notifier. So and message object, which is like we can call messages the simple object which with getters and setters. So notifier will notify in this case, and waiter so waiter waits and then when notifier notifies, waiter will just continue working here. So we can just run it, see how it works. So it's like that. Results. Okay. Also another example is the implementation of the blocking queue, where we have capacity and wait method. So to put to this blocking queue, we can just use uh, wait method and then notify method. So in this case, element when element added, it will notify the thread which waits for the take to take. So it's like it's also like the signal to the thread to continue, or items can be like the signals to send from each to other. We can use notify all method also. Wait has another implementation. It's like long time. It's timeout, so we can just specify nanoseconds as a second argument also timeout as in seconds it will be the first argument, so we can just use it like this, so it will be like the join method. It will work like join method. So interruption. So first versions Java has a stop method, but stop method is not safe because it will kill the thread in any way. So, but it's not recommended to use stop method. It's deprecated. So we have a interrupt method which signals to the thread interrupted, so we should use like this. So while interrupted in while argument, so in this case interrupt method will not interrupt method will not interrupt our thread. It will not stop our thread. It will just say to this thread, signal to this thread that this thread is interrupted by another thread. So using interrupted method, we can just, it's a static method, we can just find out if this thread interrupted uh, from the other thread. So in this case, when we call interrupted, the flag returned and immediately set to false. So once, so and then when interrupted repeatedly, so again, it will just take a true value. Is interrupted is not static method. It's so we can just check any thread if this thread flagged as interrupted. Also, Java provides a convenient way to group multiple threads in a single object. Java thread group is implemented by Java lang thread group class. So, thread group represents a set of threads. So, there are several functions, methods of this class. So, let's see an example. So, example is here. So we can just add thread to the thread group using constructor of the thread. So in this case, so super constructor, it uses super constructor, and then we can just check this group's active count, use any kind of its name of the group. It can just contain several groups of this thread, so it can just make hierarchy. Check access, destroy this group, and interrupt this group. It will just interrupt all threads of this group. Also, Java provides daemon threads, so daemon threads will be undefined using the daemon method of the thread class and check it by its daemon method. So daemon thread is a service provider thread that provides service to the user thread. Its life depends on the mercy of user threads, so when all the user threads die, JVM terminates the thread automatically. Usually demonstrate use it for functionalities that are not critical to system. For instance, logging thread, monitoring thread, and If you are not okay with a thread being terminated, don't create it as a daemon thread. So also Java provides. So let's see some example of the daemon thread. So we can just set daemon like this, and then using this method, and then start it. And also we can just use testing method. So it's in a while. When this thread finished, program finished, the daemon thread will be finished automatically. It takes 30 seconds. If we are not taking thread daemon, then we can see it how it works. So main thread finished after the main method uh, finishes completed, but daemon thread is terminated with the main thread. So main thread finished here, but daemon thread, not daemon thread, continue working. When we kill process, it will be terminated. Timer. Java timer class is thread safe, and multiple threads can share a single timer object without need for external synchronization. Timer class uses Java util task queue to add tasks at given regular interval, and at any time there can be only one thread running the timer task. For example, if you are creating a timer to run every 10 seconds, but single thread execution takes 20 seconds, then timer object will keep adding tasks to the queue, and as soon as one thread is finished, it will notify the queue and the thread will start executing. So let's see it on example timer. So we can create it using extending timer task class, override run method, 20 seconds, and then we can just using timer and using schedule at fixed rate function, we can just use delay and period where timer starts. Using cancel, we can cancel this timer. It provides us several methods. So it started, finished, started. It takes some time. sometimes. Okay, it takes some time. So let's wait. So timer task cancelled and timer task finished. So timer task finished. So it shows when thread interrupted. Okay, then also Java provides shutdown hook. It use it to clean up all the resources. So using add shutdown hook, we can just create shutdown hook to the thread as thread. For example, let's write some example for this shutdown hook. Okay, let's write it. Fetch. So, for example, we have this thread like here. And then don't start this thread. We can just use runtimes. Method and then run it. So when our Java finished, so it runs shutdown hook here. Oh, like this, we can just okay. Let's not write here. So we can take shutdown hook. It seems that it writes to the thread. Okay, so there are references where you can just read about multi-threading applications in Java. So this video is over.